One. Hello everyone, thank you for attending on time. We are starting this session about networking in Python. So we are going to cover this part. Also, I have a very nice video adding more to the knowledge we are gaining and discussing in this presentation. So after we finish our delivery and after we finish the presentation, of course, I will play the video, but not recording it. It's against the rules. So I shared the link already on both Connect and Discord, the link for the video with the additional information. So first, you remember from other units that we have API, and we said the API is a contract between two parties. So we need to communicate with the network, and here we are using what's so-called socket. Let me go to this drawing so you can see what's happening. So on the left, we have the application. So let's say I need to print the statements or salaries or some files from my application, and I need to use the network printer. So my application should communicate with TCP port, then it will reach the network printer, and sometimes we call it print servers. So then we print there. After printing, of course, the printer will tell me print job is done, or there is an error, there is no ink, there is no paper, and so on. So I should have two-way communication. So this is the whole idea of having the socket function or more than function in my application. So from the name function or module, we mean it's component of the application. So in my application, I will have different components, one for saving files, one for opening file, one for printing this file, and so forth. So we discussed modules in previous sessions, but just a refresher. So here, maybe this part is not clear enough in the presentation. We have buffers. Why we have buffers? Because of the different speeds of the different components. So this TCP port, it's a logical port on my physical network card, whether this network is wired or wireless. So it's a physical network card, and it transfers data based on some speed there. My RAM has also different speed. My processor has different speed, and so on. So different components, hard drive, and so forth. So different components with different speeds. That's why we need buffers. So data will queue in the buffer if the physical device, let's say the network card here, is slower than the RAM. So the data will queue there. Coming back could be also the same. So we need to create the application, or as a team, it's a big application, like for example, Microsoft Word or Excel, and we need to print on the network printer. So we need socket functions there. Good. What they are telling here, HTTP server to create a simple server. So http.server as an example. So there are many libraries and the APIs for networking. We can get them from different forums online, different sites. We don't have to create this piece of code or block of code ourselves. We can get that from different resources online. No need to reinvent the wheel. So as mentioned on the presentation, a socket contains a set of input-output buffers. So it will track the status of the or the state of the connections and data in the buffers. So it will track that so we don't lose data. It's a TCP port here. We can use other ports also. So creating that, so you can ask the system to create a socket for us. So a socket variable is an object. So import socket, import sys, then the note here saying create a TCP IP socket. So sock equals socket.socket, then we are getting the sock stream, inet, we are getting the data. We can also create UDP IP socket. Anyone can tell me the difference between the TCP IP from networking point of view? Anyone can help with that? Give me some input. Difference between TCP IP and UDP protocols? Anyone can tell me anything, any difference between TCP and UDP? UDP has no handshake. Okay, correct. Anyone remember the numbers? Socket number or port number, I mean. Faster, UDP faster, yes, because it is not a three-way handshake. It will not check for the data. So UDP used mainly for downloads. So it's faster because of that. TCP will make sure each packet delivered to the destination correctly. We can have attacks on UDP more than TCP. So we will discuss furthermore. Thank you for your input on the chat. So once we have a socket, we can connect it to a server using TCP. So here, create a server name / port pair. So this is the node here. Then server address equals, for example, www.google.com, and we are connecting through port 80. So this is a TCP connection, and it's HTTP. Okay, open a TCP connection to a server. So sock.connect server address. So the connect will raise an exception if the connection fails. So if the connection fails, we will see an exception, as we discussed in the previous session. Being a server, so if you are a server, if you want to be a server, we need to bind our new socket to an unused TCP or UDP port on the system, and here we can do that. So binding to a local port, so sock.bind 127.0.0.1. This is the loopback connection. I mean address and IP address. Then 53. This will raise an exception if we cannot bind to the port that we want. Note, if we used 0.0.0.0 can be used to mean any IP address we have on the system. So communicating with the other end, once you established the connection between the client and the server, so each side can send and receive data, so we can know exactly whether our document is printed on the printer, whether the printer sending some exception or some errors, there is no ink, for example. Okay, so here the example we have, read up to 100 bytes from the server. So data equals sock receive 100. So this is in bytes. So 100 bytes. If you remember, the kilobyte is 1024 byte, and the byte equals 8 bits. Then the mega equals 1024 kilobyte. So then gigabyte 1024 megabyte, then terabyte 1024 gigabyte. So send data to the server. For example, num bytes sent equals sock send. So sock receive, sock send, hello there. If again, if the TCP connection fails or one side closes the connection, we are getting exceptions. Good. Either side of a TCP connection can close the connection. So after that, we need to close the connection. So sock.close, and this is the function. Then this is for the TCP. For UDP, it's almost same thing. It's connectionless. We can send the datagram, user datagram protocol. So this is the abbreviation for the TCP transmission control protocol. So we can send a datagram once we know the IP port of the other end. So here, create a server name / port pair. So server address google.com, 80. If we are getting UDP, so send data to you to a UDP server. So sock.send to, hello there. Then we put the server address. Exceptions as per usual. When we receive UDP data from someone, we also obtain their IP address and port, so we can reply. So here we are creating UDP IP socket. So sock equals, this is a variable name, we can give it any name, but we're using meaningful, as we agreed, we are using meaningful names. So sock equals socket.socket, then we open parentheses and socket af inet socket.sock datagram. Bind to a local port. So sock bind 127.0.0.1, 53. Receive data from a client up to, for example, 1024 bytes, 1 kilobyte. So data address equals sock receive from. I think up to bytes data. So this data is here. So this is related to this sentence. So the variable starts here, address equals sock.receive from, then 1024. Okay, and we mentioned here the IP address and the port number. The typical TCP client structure, we create TCP socket, connect to the server, send the client request, then read the server response, close the TCP connection, do something with the server response, print, save, delete, and so on. So that was the client structure. From the server side, so the server structure, we are creating TCP socket, bind to local port, then forever accept the connection, get the client's request, perform the request, return the response, close down the connection. But the server can still receive other requests, other connections from other clients, or even the same client. So we are just closing down the connection, not the port. So we can get more connections because this is a server. Okay, so it should be up and running as 24/7. Okay, here, this one, it's about HTTP protocol. By the way, if you are missing anything or you feel it's a bit challenging, feel free, as usual, ask me questions. Then we will watch this video I mentioned. Then we can discuss further. So client connects to server, issues either a GET or head request. So head, only metadata about file is returned. So this is the head of the data, or what we call metadata, like file type, size, what is there, and other data, maybe IP address, maybe destination, source, and so forth. Location, if it's a photo, so the location, time, date. Get metadata and file, both of them will be returned. So this is the difference between head and get. So the server will return HTTP /1.1 200 OK or 404 error. So if it's 200, it's OK. 404, it's an error, plus the file metadata, blank line, the file itself, which could be an error file. So example. So here we are getting get from the file name index.html, HTTP 1.1. So 200, which means OK. Then server, simple Python server, content length 196 bytes, type text or HTML. Then we are getting HTML code, head, body, then web server Python, source code, and so forth. Some PNG images, some pages. And here, this is the simple web server structure. So the difference between the server and the web server, we share folders on the web server, and this folder becomes a website, as simple as that. So the web server is a normal server, and we share resources there. These resources are folders and files, of course, and this is the website. We have IIS from Microsoft, and we have Apache server, the Linux server, the most common web servers. We have, of course, other types like Unix and other types of web servers. So the difference between the web server and the normal server, other servers, just what type of resource you are sharing. And of course, the web server should be accessible by everyone, or at least some people, so it has a public IP address. The server could have local private IP address or public IP address. It depends on its function. For example, if it's a mail server, again, we need a public IP address, or we can use some gateways and so forth. So simple web server structure here, we will create the TCP socket, bind to a local port, then accept a connection. And this is again forever, 24/7, get the client's HTTP requests, parse the request, error if it's nonsensical, then perform the request, get file size and content, error on failure. So return the proper HTTP response, close down the connection. So this is the same thing with our browser, by the way, but we don't see that and we don't need to do that. But if we are programming that, we need to follow these steps and follow this structure. So we have example here for our web server.py Python one. So call structure, main program, bind to a port or bind to port, then server loop, we are getting accept, handle request, close, or receive, perform request, send, parse request, get file size, read, HTTP error, if we have. Some methods here, API docs. So these are the simple web server, some method API docs. So documentation here, we are using hashes for documenting that. And yeah, yes. So on the chat, there are some some discussion about Apache and the vulnerability with log4j. Yeah, thank you for sharing these articles about the log4j for Apache server. Okay. Some method API docs also, so good idea to go through them, read them. And in Python 3, we have built-in web server. So it comes with a method library to do web service. So the name is http.server and the example in front of us. So we are importing, import http.server, import socket server, port 8000, then handler http.server dot simple HTTP request handler, then with socket server.tcp server space port handler as HTTPD, print serving at port HTTP.serve forever. More to come, built in web server. Even better, a single Linux command line command. So Python /m http.server 8000. Documentation, here the link, and we will use that if we need it. Of course, we can use the existing high-level library from any resources. So this is the part here. After that, of course, we have the exercise. So we have some exercises here, really good good idea to go through these exercises and discuss further on Discord. So I will display the video in a moment. Then after that, after the video, we are getting a break. Then we'll go to the second part. Any question before I stop recording? Any question? Okay, thank you. I will stop recording now, then I'll play the video, or do you want to play the video after the second part by the end of the delivery?
I'll play it now, Sam.
Okay, good, no problem, thank you. I will play it now.